So your RQ could also be influenced by what you consume or what you eat. So in this case, you're consuming a carbohydrate beverage, and your muscles will take up the glucose from that beverage and oxidize it as a fuel source. And that's a strategy that's used by some endurance athletes to preserve muscle glycogen stores during very long duration performances. So it would actually help to consume carbohydrate beverage in that situation. So this next set of review questions, the first one, why do people who are endurance trained have a faster rate of glycogen resynthesis after an exercise session than untrained people? And it mainly has to do with those GLUT4 transport proteins. So with endurance training, you get an increase in GLUT4 transport proteins, and that allows a faster uptake of glucose into your muscle after an exercise session. And that glucose can then be made into glycogen. So you get greater glycogen resynthesis. So faster glycogen resynthesis in aerobically trained people because they have higher GLUT4 transport proteins in their muscle. The second one has to do with kind of a review of enzymes. So specifically a review of mitochondrial versus non-mitochondrial enzymes. So the question is, who would most likely be endurance trained? So you've got an individual with a high ratio of lactate dehydrogenase to lactate dehydrogenase H to lactate dehydrogenase M, or someone with a low ratio. So if you're looking at ratios, you're looking at LDH, and this is the H form, to LDH M form. So the H form stands for heart, the M form stands for muscle. This one is higher in mitochondria, and this one is located outside your mitochondria. So if you have an increase in this ratio, you're getting an increase in this mitochondrial enzyme compared to this cytoplasmic enzyme, and it would indicate that you're more aerobically trained. So part B is an individual with a high ratio of phosphofructokinase to citrate synthase, or a person with a low ratio. So again, going back to the whiteboard, if you're looking at phosphofructokinase, so PFK, and then you're looking at citrate synthase, if you go back in your notes, PFK is found in glycolysis, whereas citrate synthase is found in the Krebs cycle. The Krebs cycle is in the mitochondria, so in this case, this is your mitochondrial enzyme, and this is your cytoplasmic enzyme outside the mitochondria. So if you had an increase in citrate synthase relative to your PFK, then this whole ratio would be decreasing. So if you divided this number by this number, it would be decreasing if this number was increasing. So your correct answer here is it's an individual with a low ratio of phosphofructokinase to citrate synthase that would be more likely to be endurance trained. That low ratio is caused by the higher citrate synthase and not necessarily a lower PFK. So that again is your mitochondrial enzyme. This is your cytoplasmic enzyme. In the first example, this was your mitochondrial enzyme, and this was your cytoplasmic enzyme.